Welcome back to College Algebra. This is the first of Chapter 5. We're going to be talking about Section 5.1 today, which has to do with a new kind of functions called exponential functions. Before we get started, just a quick reminder, homework and quiz number 11 contains sections 5.1, 5.2, and 5.3, and it is due Tuesday, April the 14th at 11:59 p.m. Central Time. This is the first material that is on this homework and quiz. So let's get started. As I said, this is section 5.1 and it does talk about something called exponential functions. So the exponential function is some type of function with a base of b. We write it as either f of x is equal to b to the x power, or we can replace f of x with the variable y, and we can write it as y is equal b to the x power. B must be a positive number, and it can't be equal to 1. If it's equal to 1, it's a very boring function. X, my exponent, can be any real number, but please notice again, b, the base, must be positive. So we have a very special exponential function, and it's called the natural exponential function. And this is the function when the base is defined as the value e. E is Euler's number, and it is approximately 2.718, etc. We just use the constant e. E is kind of like pi in that it's an irrational number, but we'll just write it as e, and it is on your calculator. So, to make sure that you can use your calculator appropriately and correctly for these problems, I need you to, if you don't already have your calculator out, I'd like you to go pause this video and get your calculator, because you're going to want to make sure that you get the same answers that I do when I use my calculator here. So in this particular problem, you're going to want to put 2 11ths in parentheses. Most of you have like a little caret button on your calculator, so you'll do it open parentheses 2 and then divided by 11 and close parentheses. You can use the caret button. You might have a y to the x button, and then you'll put in that exponent of 0.7, and then when you push the equal sign, you will get the value 0.30321118. I'm going to go 7 decimal places because it says to round to 6. I want you to see the 7th place is 8, and so we are going to round that up to 0.303212. So this is going to round up to 2. So go to the 7th place and round to the 6th decimal place. All right? Easy enough. Okay. So for the next one, you're going to use the E button on your calculator. For most of you, the E button is the shift of the LN or natural log button. So you may have to kind of play with your calculator to see how this works. But if you do this correctly and raise e to the 5th power, you should get 148 point, and I'm going to go 6 decimal places, so 413, and then it is 159. The number after this, the digit after this is 1, so it's going to stay at 9. Okay? All right. If I raise e to a negative power, so this is going to make it smaller, but it's not going to make it negative. So in this case, when I put in my calculator, make sure you do put the negative 0.2. You're definitely going to want a calculator for these problems. And so I should get this value 0.818, and then 730 is the next digit, but the last one is 7, so we're going to round this to 31. And that's my final answer. So if you do not have your calculator handy, I highly recommend you go find one. Make sure that you can punch these numbers into your calculator to get these answers, just to make sure you can use your calculator. Okay. So now this next problem has to do with graphing these functions, and when we graph exponential functions, we're going to actually use a table of values, and I'll scroll this down just a little bit so you can see this whole table here. So MyLabs Plus is going to give you x values, it's going to ask you to find y values. You might not have this column, it might just be the column where the ordered pair is, but I'm going to give you this extra one, and then we're going to actually graph this and see what they look like. This one and one more, possibly two more, we'll see. Okay, so if x is -3, then I'm going to be finding, -2, sorry, I'm going to be finding f of -2, which would be 3 to the -2nd power. 3 to the -2nd power, we recall, hopefully, is the same thing as 1/3 to the +2nd power. We talked about this at the beginning of the semester, which gives me a y value of 1/9. Now, I know this may not be super easy to graph, but I'm going to show you how to make an estimate of this. So -2 +1/9 is my first point. So I'm going to go ahead and graph that. -2 +1/9 is going to be relatively small here. It is not 0 and it is not negative, so that's probably the biggest thing you need to recognize. Let's do x is -1, and so I'm going to be finding f of -1, which is going to be 3 to the -1st power. Again, my negative exponent flips this over and makes it 1/3 to the +1st power, which is just going to have a value of 1/3. So my f of -1 is 1/3. That tells me my ordered pair is -1 +1/3. And so again, I'm going to go ahead and graph this while I'm at it. 1/3 is a little bit larger than 1/9, so it's going to be somewhere approximately in here. Okay. For the next value, I'm going to use x is 0. So I have f of 0 that I want to find. This is 3 to the 0 power. Any number raised to the 0 power other than 0 is 1. And so my y value here is going to be 1, and so I have the ordered pair 0, 1. This point is actually called my y-intercept, and we've talked about intercepts recently, so this is kind of a nice way to remind you of that. So here is my point 0, 1, and that is that y-intercept. So the next point is when x is +1, so I have f of 1, that's 3 to the 1st power, which is very nice. We don't need a calculator for that. We get a y value of 3, so I have the ordered pair 1, 3. We'll go ahead and graph that, 1, 3. And then finally, my last point is going to be when x is equal to 2, and so I have 3 to the 2nd power, which we shouldn't need a calculator for that either, has a value of 9, and so my ordered pair is going to be 2, 9. Notice that these values are getting pretty large pretty quickly, and that's usually a feature of an exponential function. So let's see if I can connect all of these together with a relatively nice smooth curve, and we'll keep going up here, and we get the idea. Okay, now keep in mind this graph gets very close to the x-axis. It is never going to be equal to 0, so it does not have any x-intercepts, so no x-intercepts. That's going to be important later on, so no x-intercepts, and it's always going to be positive. So the domain for our exponential functions, just in keeping with what we've been talking about, is all real numbers. I can plug anything in, but the range for my exponential function is 0 with an open bracket to positive infinity. If you are headed to business calculus after college algebra, you will see these exponential functions again, and we will expect you to remember this. Okay, let's move on to the next one. So same kind of problem, except now I have a 1/3 to the x power, so that's going to be fine. We're going to start with -2, so if I want to find f of -2, this is going to be 1/3 to the -2nd power. That's going to allow me to flip this over and become 3, or 3 over 1 to the 2nd power. And this is going to have a value of 9. I did this intentionally where we did 3 to a power on one side and 1/3 to the power on the next problem, so that you can see what's going to happen here. So if I were to graph this, -2, +9, it's going to be a point right about here where I finished out my problem. It's okay. The next one is going to be f of negative 1. So again, we have 1/3 raised to the power of, there's my exponent. I'm going to flip this over, and this gives me 3 to the first power. So my y value here is 3. I did forget to write in my ordered pair, so let's go back and add that. So we're consistent here. We've already graphed it. So let's graph negative 1, positive 3. So notice what's happening on this side. My values are here, and now they're getting smaller. In the previous ones, they were small, and they got large. So let's go with x is equal to 0. So I want to find f of 0. F of 0 is 1/3 to the 0 power. Again, 1/3 to the 0 power is going to be positive 1. So I have, again, that y-intercept. So 0, 1 is my y-intercept, the place where the graph crosses the y-axis. When x is equal to 1, I'm going to be finding f of 1. So I have 1/3 to the first power. That's pretty nice. That is 1/3. So I have the point 1, 1/3. So if I graph that, it's going to be about here. These are going to be kind of approximations because those are really hard to graph. And then finally, when x is 2, I have f of 2. We'll kind of drop this down here. I have 1/3 squared, and that's going to be 1/9. And so this is going to be the point 2 and then 1/9. 1/9 is smaller than 1/3, so it's going to be about here. Again, no x-intercepts, no negative values. So when I connect these points by my nice little curve here, they're going to come down and get very close to this axis, but they are not going to cross it. It doesn't turn around and go back up, and it doesn't cross this. So again, no x-intercept and no negative values. So the domain is still negative infinity to positive infinity, and the range is still 0 to positive infinity. Notice no square bracket because it doesn't actually get to 0. Okay? All right. So let's talk about what we can do with exponential equations. So we've solved regular kinds of equations or linear equations and quadratics and lots of other types of equations, but now we're going to be solving these equations where the variable that we're trying to solve for is actually the exponent. And so our exponential equations thus. So in order to do that, there's a couple of different ways to solve exponential equations, and we're going to talk about the method referred to as relating the bases. And so we want to be able to write both sides of our equation so that I have the same base. And sometimes this is easier than it is at other times, and sometimes you can just look at this and go, oh, I know the answer. I know some of you are already thinking that. But we're going to take this and we're going to write both sides of this equation as 2 to a power, because I can write 16 as 2 to a power. So on the left-hand side here, I have 2 to the x power. So we're going to rewrite that as just 2 to the x power, not changing anything. 16 is 2 to the, not third power, but 2 to the fourth power. So now I have my bases are the same. And as long as the bases are the same, then we can say that these two exponents are equal to each other. So we can drop those bases essentially and say, okay, x is equal to 4. And some of you were like, yeah, but I knew that already. And you did, but this one is a nice problem, so we give you one nice one to begin with. Okay, now not all exponential equations can be solved like this, but the ones we're going to solve in this section, you will always be able to write them with the same base on both sides. Okay, so let's move over here to number 7, and we see we have 3 to the x minus 1 power. So we have a 9 on the right hand side, and we can write 9 as 3 to a power. So we will keep 3 to the x minus 1 over here on the left hand side. I'm going to take little steps here because you can't ask me questions about this, so I'm going to try to take little steps. 9 is 3 squared, so that's my first step. But I have 3 to a power and I have 1 over 3 to a power, and that is completely different. So I'm going to keep 3 to the x minus 1 power, and I'm going to flip this, and this is going to become 3 to the negative second power. Just like we flipped those on the previous slide to be able to graph those functions, we can also flip any number raise it to the numerator, flip it over, and change the exponent. Just a real quick reminder, we did this back at the very beginning of the semester. If we have something to a power, we can rewrite this as 1 over that to that same power. If I have something to a negative exponent, I can rewrite this as 1 over that same base to the positive exponent. Okay, so same thing. Okay, oops, that's a negative, sorry. Okay, there we go. All right, so numerator to denominator, the exponent changes signs. Okay, all right, so now we've got 3 to the x minus 1 and 3 to the negative seconds, so our bases are the same, so we can say now that our exponent of x minus 1 is equal to our exponent of 2. Now we can very easily solve for x. We add 1 to both sides, and if I add 1 to both sides, I get x is equal to negative 1. Okay, so we're adding that 1 to both sides. And that is my final answer. I could plug it in and check, and I'll get 3 to the negative second power is 1/9. Right? So these are a little bit harder because now I have these e's running around in here, but we still can write both sides as e to a power. The left-hand side on this first one is nice because it is e to a power. So it's e to the 5x plus 2 power. On the right-hand side, I'm going to translate this cubed root into the 1/3 power. And we've talked about this before. So a cubed root is 1 over, in this case, 1 over 3. So kind of an aside note, if I have something raised to the 1 over n power, this is the nth root of that number. Okay, so just to remind you of that little translation there. So now I have e to this power is equal to e to this power. The powers are going to be equal. So 5x plus 2 is equal to 1/3. I can subtract 2 from both sides. So if I subtract 2 from both sides, I have 5x is equal to 1/3 minus 2. Real quick reminder about this. Common denominator is 3. So 1/3 minus common denominator, 3 times 2, this gives me 6/3. So I have 5x is equal to negative 5/3. Another reminder is that if I divide by 5, that is the same thing as multiplying by 1/5. So I divide the left side by 5, I multiply the right side by 1/5. This gives me x is equal to, my 5's actually divide out, and so I have negative 1/3. So because my 5 and my 5 divided out. So my final answer here is x is equal to negative 1/3. Number 9, I have to remind you that when you raise a power to a power, you multiply those exponents. So another quick reminder over here, if I have x to the second power, and this is all raised to the third power, then this becomes x to the 6th power because I multiply these exponents. So when I raise e to the x squared to the second power, I multiply these two exponents, and this becomes e to the 2x squared is equal e to the 8th power. So now my exponents can be set equal to each other, so that means I have 2x squared is equal to 8. I divide both sides by 2, I get x squared equals 4, and I take the square root of both sides. Being very careful here, I do get plus or minus the square root of 4. Since I can simplify the square root of 4, I get positive 2 and negative 2. And so I actually have two solutions for this particular equation. Okay? Excellent. All right, so now we're going to talk about some applications. These are formulas that we will give you on the test. They may not be on your quiz, but you can still use your notes for your quizzes. So I would make sure you write this down before you take your quiz. But on the test, we will give you this formula. Now, I will not give you this explanation, so I'm going to expect that you remember how to use the formula. So P stands for principal, or sometimes this is referred to as the amount invested, okay, or what we start with, okay, so the amount invested or what you start with. A is the total amount after T years, so this is also known as the final amount. So that's kind of helpful here, okay. R is your interest rate per year. Please remember this must be written as a decimal, so if it is, say, 4%, then I'm going to use R as 0.04. So just remember that we have to take the percent and divide it by 100. So 4 divided by 100 gives me 0.04, or you can just remember that you move your decimal 2 places to the left. Okay. N is the number of times compounded in a year. So I'm going to talk to you about that in just a second. And then T is going to be the number of years. So we have 4 basic numbers that we're going to use for N. So if it says, and I'm going to come over here and make you a chart. So if the problem says compounded annually, so that is the first possibility. So compounded annually. This means that N is equal to 1. So it's 1 time per year. Okay. If the problem says that the interest is compounded semi-annually, okay, so semi-annually, I think I misspelled that, then N is going to be 2 because it's going to be compounded twice a year. Okay. If it says compounded quarterly, well, there are 4 quarters in any one whole, and so N is going to be 4. And then finally, the last one that we're going to do in this class, if it says compounded monthly, so a year has how many months? Somebody usually says 13, and that just really disturbs me, but it's okay. 12 months are what a normal calendar year has, so we say N is equal to 12. You need to know these. So on your test, there's not going to be anything that tells you that annually means N is 1, that quarterly means N is 4. So you need to know if it says compounded annually, N is 1, semi-annually 2, quarterly 4, monthly 12. Okay, those are the only 4 things you're going to use for this formula, and I'm going to show you how to use the formula. Okay, so let's move over here and work this problem. So this says find the accumulated value. So this is the value of A that we're looking for. Okay, so that's another name for A, the final answer, the accumulated value, the final amount, okay, of an investment of $9,000. So here is P, okay, for 10 years, so here is T, number of years, at an annual interest rate of 3.5%, so R is going to be 0.035. If the money is compounded quarterly, and this means that N is going to be 4 because compounded quarterly means N is 4. And now we're going to be looking for A and plugging everything else into the calculator. All right. So A is going to be equal to, we'll start with 9,000, and then we'll have a parentheses raised to a power. In that parentheses, we're going to have 1 plus our interest rate of 0.035 divided by our number of times compounded, which is 4, raised to the power of, now I'm going to suggest you put this in parentheses, N is 4 and T is 10. So put this in parentheses, okay? Be really careful when you enter this into your calculator. I can't pull up the calculator to show you, but I'm going to write all of the steps down, and then I'm going to give you the final answer that you're going to need, and I may give you some pieces along the way so that you can do pieces of this. You can actually put all of this into your calculator at once. So you would say 9,000 times, and then open a parentheses. You can literally type in 1 plus 0.035 divided by 4, close your parentheses, and then use either the y to the x or the caret button, open parentheses, and type in 4 times 10. You could do this as 40 if you wanted to. If you do this correctly, you will get $12,752, and we always round to this 2 decimal places, so it's 179, so we have 1.18 cents. And that's my final answer. So after 10 years at 3.5% interest, $9,000 becomes $12,752.18. Okay? All right. So the other formula that we have for interest is called compounded continuously. Notice that this does not have an N in it, okay? A is still my total amount after T years, also known as that accumulated value, right? P is still the principal or the amount of investment, so the amount invested. R is still the interest rate per year, so remember we have to take that number divided by 100. And T is still the number of years. The difference is that I've replaced that big parentheses with the E, okay? So we'll be using E on the calculator here. So if it says compounding continuously, so continuously compounded, there is no N, all right? So don't try to find an N for this problem. All right, so find the accumulated value of an investment of $6,000 that's been invested for 20 years at an annual interest rate of 6.25% if the money is compounded continuously. This statement right here tells you to use this formula. Okay, so let's go through this again. We're looking to find the accumulated value. So this is A, that's what we're trying to find, where our principal or the amount invested is P, our time is 20, and our interest rate is 0.0625. Okay, so we have to move our decimal 2 places. All right, so let's find this. So A is equal to, and we have 6,000 times E to the, and I would put this in parentheses, so we know that the interest rate is 0.0625 times the time of 20 years. Okay, and we're going to type all of this into the calculator just like that, putting this in parentheses. And if you do that, if you plug this into your calculator, then you're going to get, so we do 6,000 and then you can do times and you'll get your E button, and then most calculators go ahead and open up a parentheses there. If yours does not, I encourage you to open up a parentheses, and this is going to give me $20,942, and it's 0.057, but we're going to round that to 0.06, so 6 cents. Okay? Excellent. Very good. Make sure you know how to use your calculator before you get ready to take your quiz or your test, because otherwise that could be just absolutely crazy. So just be careful. Okay. Last question in this section Says most people who start a serious weightlifting regime initially notice a rapid increase in the maximum amount of weight that they can bench press. After a few weeks, however, this increase starts to level off. The following function models the maximum weight that a person can bench press in pounds at the end of T weeks. Here is the function. You do not have to create this function. We would give you this function. What I want you to be able to do is to use it. So the first question says, what was the maximum weight that this person can bench press initially? Initially means T is equal to 0. Okay, that's what initially means. So when they started off, there's 0 weeks into this program, so T is 0. So what we want to do on this first part is to find W of 0. So this is 250 minus 120 times e to the negative 0.3 times 0 power. Well, I'm going to take a little step in here and make sure that you simplify this correctly. E to the anything times 0 power is going to be e to the 0 power. And e to the 0 power, we don't even need a calculator for this as it turns out. E to the 0 power is 1. You remembered that. And so since e to the 0 power is 1, I have 250 minus 120. So according to this, you should be able to bench press, or this particular person could bench press 130 pounds initially. Okay, so we just do 250 minus 120. All right. So at the beginning of this program, this person was able to bench press 130 pounds. That is definitely not me. I will never be able to bench press 130 pounds, so that's another story. Okay, so the next part is, what is the maximum weight that this person can bench press after 3 weeks of lifting weights? So it should be more, right? They've learned to do this. So this is where T is going to be equal to 3. So for this problem, I need to evaluate W of 3. Now I am going to use my calculator for this. I'm certainly not going to try to do this without the calculator. So 250 minus 120 times e to the negative 0.3. I'm going to go back, put this in parentheses to make it a little bit easier to make sure we get everything in. Negative 0.3 times 3. Okay. And so now I'm going to simplify this. I'm going to take a couple of little steps along the way just to make sure that you guys don't get lost. I would probably go ahead and take your calculator and multiply those two together, because I just think it keeps you out of trouble. Very easy to get some things lost in here. So this is negative 0.9 for this exponent. Negative 0.3 times 3 is negative 0.9. So I would probably go ahead and do that. And so now that's going to be the exponent for the e. So I'm going to give you that value separately rather than putting all of this into the calculator at once. You can do it however you want to, but 120 times e to the negative 0.9 is 48 point, I'm going to give a couple of decimal places here, 79, and then I would subtract that from 250, and you should get 201.2 pounds. Okay, and that's my final answer. Okay, I'd love to say any questions, but if you have questions, please email me or come join us in our WebEx session. That's all for this section. Y'all have a great day. Bye.